Hey there fellow science enthusiasts. Welcome back to our channel, where we dive deep into the exciting world of cutting-edge research. Today, we have a groundbreaking topic to discuss, one that holds the promise of transforming the way we understand hair regrowth and cell biology. Get ready to witness the amazing potential of a tiny particle called miR-205. In recent years, researchers have been unraveling the secrets hidden within our very own genetic code. One area of immense interest revolves around the role of RNA, a crucial molecule that serves as a messenger, carrying vital instructions for cellular processes. And within the realm of RNA lies an extraordinary particle, miR-205. miR-205 is a microRNA, a specialized type of RNA that has captured the attention of scientists due to its remarkable ability to influence cellular behavior. What makes miR-205 truly fascinating is its role in cell softening, a key factor in hair regrowth. Imagine a world where we can address hair loss, a challenge faced by millions worldwide, with a simple solution that harnesses the power of miR-205. Well, groundbreaking research is currently underway to turn this dream into a reality. Scientists are conducting extensive studies to understand how miR-205 can be harnessed to relax the hardness of cells in hair follicles, thereby promoting their regrowth. By exploring the intricate mechanisms through which miR-205 operates, researchers are inching closer to unlocking the key to stimulating hair growth in a way that was once thought impossible. Exciting, isn't it? The journey toward understanding the impact of miR-205 and its therapeutic potential is just beginning. Join us as we delve deeper into the world of this tiny particle, exploring the latest research breakthroughs, and uncovering the remarkable implications it holds for the future of hair restoration. So, if you're as passionate about the wonders of science as we are, make sure to hit that subscribe button and ring the noti.
In this article, researchers claim that by using a tiny RNA particle, they may have discovered a way to promote hair growth. They continue by stating that both old and young mice showed improved hair growth after receiving this treatment. Experts agree that additional research is necessary, but if the procedure is successful in curing baldness in humans, it might represent a significant advance. Northwestern University researchers claim to have found a discovery that may make a lot of men extremely happy. According to the researchers, they may have made progress in understanding baldness and hair development. According to their research, which was first reported in the journal PNAS, human hair follicles stiffen with age, making it more challenging to grow hair. The process is comparable to how aging joints can get stiff and make movement more challenging. The researchers point out that if the hair follicles are softened, which increases the likelihood that they will generate hair, it may be a different scenario. Information on the trial to treat baldness. Scientists claim to have discovered a method to stimulate hair growth in mice by softening the stem cells by increasing the production of a small RNA particle called miR-205, which reduces the hardness of the cells. The authors claimed that hair growth occurred in both young and old mice after genetically altering the stem cells to create more miR-205. They started to grow hair in 10 days, said Rui Yi, Ph.D., a professor of pathology and dermatology at Northwestern's Feinberg School of Medicine in Illinois and a senior author of the study. Yi remarked that no new stem cells were being produced. "We are promoting the growth of hair using existing stem cells. We frequently still possess stem cells, but they might not be able to produce hair." Controlling hair growth in cells. Yi said that by controlling cell mechanics, scientists have shown that it is possible to increase hair growth. "We will test next whether topically applied miR-205 may stimulate hair growth initially in mice," he added. Because of the possibility to transfer microRNA through nanoparticles directly into the skin. If successful, trials will be planned to see if this microRNA might potentially encourage hair development in humans. The team used two-photon microscopy to observe cell activities in live animals and atomic force microscopy to evaluate stiffness to conduct the study in genetically modified mouse models. The study, according to Irvine, California-based surgeon and inventor of Orange County hair restoration, Dr. Ken Williams Jr., was nicely designed and has hopeful translation to humans. The difficulty, according to Williams, is that the mouse model does not always correspond to the same human data. I want to lower any high hopes for these outcomes. The efficacy or benefit of these research cannot yet be determined. We believe that when it comes to using it on humans, more research will be beneficial. Alternative hair growth techniques. Williams also mentioned that numerous drugs that are currently undergoing clinical trials may also be helpful for people. As of today, DHT inhibitors like finasteride and hair growth stimulating drugs like minoxidil are among the most effective medical treatments available. Low laser light therapy (LLT) and platelet-rich plasma (PRP) are two more popular regeneration therapies that have been shown to be safe, acceptable, and effective, he added. Williams claimed that previous techniques, such hair cloning, have appeared promise in animal experiments only to fail in people. Williams stated that hair cloning has been attempted for more than 15 years, with positive results in animal models but negative effects in humans. What aspects affect hair growth? The founder, chief medical officer, and medical director of Bauman Medical Hair Transplant and Hair Loss Treatment Center in Florida is the hair restoration surgeon Dr. Alan Bauman. According to Bauman, each patient's specific DNA and hair loss is what determines how effective different hair loss therapies are. Age is a factor, but there are countless other factors that play into it, including hormones and if a patient is predisposed to male or female pattern baldness, Bauman said. Those factors may even be more important than age to a hair follicle not producing hair. Grace, the head scientist at Culture.org, Angelique Magalit, holds a PhD in molecular biology and biotechnology. One of the most sought-after drugs ever, according to her, could represent a breakthrough in treating hair loss. Baldness is hereditary, so many people experience this, Magalit stated. Baldness has been linked to reduced self-esteem, thus having a medication to treat it would be quite popular. According to Magalit, there is a good probability that the technique will work on people. However, years of human clinical trials will be done before it's released to the market, she added. Since, between humans and mice, chromosomal counts and body functions differ, this could potentially have certain unfavorable impacts in humans that are not evident in mice. Therefore, clinical trials are necessary.
And that wraps up our captivating journey into the world of miR-205 and its potential in hair regrowth. We hope you found this video as fascinating as we did. If you enjoyed this video and want to stay updated on the latest scientific discoveries and breakthroughs, make sure to subscribe to our channel. Hit that subscribe button and don't forget to turn on the notification bell, so you never miss out on our future uploads. If you have any questions or thoughts about miR-205 or any other scientific topic, feel free to leave them in the comments section below. We love engaging with our audience and hearing your perspectives, and if you found this video informative and thought-provoking, give it a thumbs up. It really helps us out and encourages us to continue creating content like this. Lastly, we want to express our sincere gratitude to the brilliant scientists and researchers who tirelessly work to unravel the mysteries of nature. Their dedication and passion drive progress and pave the way for a better tomorrow. Thank you all for joining us today. Stay curious, stay inspired, and we'll see you in the next video. Remember, the wonders of science are just a click away. Until next time, keep exploring and keep learning.